Welcome to the dangerous side of Kotlin. Um, a little bit about me. Sana already introduced me, but just some professional background. I'm a software engineer working in the Netherlands at bol.com, named Bart Ankelaar. And I'm currently actually working as a site reliability engineer, but that's actually also software engineering. So just so you know, you can find me on Twitter as Bart Ankelaar. And if you have any questions, you're always free to mail me at my work email. So I work at bol.com, which is the largest online retailing platform in the Netherlands and Belgium. We're part of the Ahold Delhaize group. And as such, we have a head office in Utrecht, which now, of course, no one uses anymore. We work with 2,500 colleagues, reaching 3,000, I think, and we have about 10 million active customers. And through ourselves and our partners, we sell everything from toys to pet stuff, which we sell from our warehouses, which are centrally located. And we just had Black Friday, and it's hundreds of thousands of packages that we ship every day. And you can imagine that all that information goes through a large microservice landscape on the back end, where we work at around 700 engineers, I think, by now. Which is actually really dynamic and awesome place to work. So if you're looking for a job, consider bol.com, because it's great fun here. Right. So I had prepared a story about Alexander the Great, but like just half an hour ago, I found out about, let's see, that this thing here, that we've actually landed on the moon again for I think last Tuesday. The Chinese mission, the Chinese are doing a sample return mission to the moon as we speak, and I think that's absolutely awesome. So I'm just hijacking my cool story slot to talk about the Chang'e 5 sample return mission, because this is a mission of complexity that almost equals the Apollo missions, and it's been going really well here. And I think what's happening here will slot into this presentation just as good as the Alexander the Great story. So, because what's happening here is that they've sent a multi-part system to the moon on a huge rocket, where a part stays in orbit around the moon and a part lands on the surface, as they've done Tuesday. And then they're loading up, they're actually drilling down into the moon and loading up a couple of kilograms of samples, loading that up into another small rocket, which then fires off of the lunar sample return, and then connects to that orbiter, and then that orbiter is gonna return that back to the moon. So there's all these kinds of different parts that work in a complex ballet of amazing technology, all so that we can get a better understanding about the nature of our universe. And I think that's absolutely awesome. So let's keep this story in mind as I'll skip away from another Alexander the Great picture later in this presentation. Because actually, of course, I'm here to talk to you about Kotlin. And not just simply Kotlin. No, I'm here to talk about dangerous Kotlin. Right. That's a dangerous fellow over there, right? Right. So what do I mean when I say dangerous Kotlin? Of course, I don't mean like sit on a rocket, jump out of an airplane, run with the bulls. I'm not talking risk your life dangerous. And I'm also, of course, not talking hacking and dark web stuff, because I'm sure you could probably do that with Kotlin, but please don't. It's just so much more fun to do actual constructive stuff. So what do I mean when I talk about dangerous Kotlin? And what I mean is much closer to like the nature of programming languages, because ever since like the 50s, so for about 70 years or so, knowledge about programming languages and actual programming languages that have been invented. They have iterated, and they've several layers of abstraction have built upon each other, and have embraced different paradigms. And all of that centers around what I think are like the core requirements of a programming language. And if you look at something like Kotlin, there's like only three things I think that we really need from software engineering languages. And of course, first and foremost, they need to allow us to fix our problem. But theoretically, be Turing complete and you're there, but that's not really pragmatic. So fundamentally, it also really needs to make your programs easy to write, because there's so much complexity that we're solving and balancing. So translating this to a model that computers and other people will understand needs to be made as easy as possible. But then the third factor, and this is by far the most important one, is that it also needs to be read, easy to read, because yes, the computer will understand it if you do it in the way that the computer understands, but any program will be read far more times than it will be written. So the programming language really needs to be optimized to produce readable code. And Kotlin, in my opinion, really has been the superhero of the JVM world in this aspect so far. And like the way it handles nullability in its type system, the fact that it's explicit makes it much easier to work around this feature that actually theoretically breaks all type systems, and it's that why it's a $1 billion mistake according to Tony Hoare. And but there's many other awesome features like the data classes, but of course Java has records now, but also operator overloads, type aliases, function types as a first-class citizen of the type system. Absolutely great. And other things like extension methods, type reification, and other things. Awesome tools. So Kotlin brings us lots of fun and exciting and well-designed tools to write better code. With all these different variations, we can pick the tools that we need to express our intention in the best way. But there's also a risk in all these different tools, because like all these features have been fairly recently developed from computer science, and Kotlin has done a pretty good job in picking the right ones from them, much better in my opinion than, for example, Scala. But the risk is that with all these different tools also comes different ways to shoot ourselves in the foot. Previous presentation already said it. With great power comes great responsibility. So I want to take a couple of war stories and looks at a couple of these features, at how they can help you, but also how they can really hinder you. And that's where the danger is that I want to highlight right now. So let's take a look at extension functions. So if you don't know what they are, extension functions are a way in Kotlin that you can add methods to types that are declared elsewhere, maybe even in a different library, or maybe even in a standard library. For example, if you want to have a convenient way to turn a string into a URL, you could define an extension method like this, and all your strings would now have the capability to call as URL on them. And if it's not a valid URL, it'll throw a malformed URL exception. But you'd have that possibility. The problem is when you actually do this, is that you've defined this somewhere, maybe close to where you need it in a class, or maybe if you put it in a dedicated utility file. And now someone else who works on the same code base as you and needs the same functionality, but he doesn't know that you added this. So maybe he built this, which is essentially the same, only it can only also be applied to nullable strings. And maybe again someone else, or maybe you a month later, defined the same this extension somewhere else, which is almost the same and has almost the same behavior, except this one actually swallows malformed URL exceptions and turn it into null. So this actually has a nullable result. And maybe perhaps this was actually what you wanted the first time you used it, but maybe not. And now you have these free instances of a conversion to URL lying around your code base. And so if there's now an issue and your stack trace says as URL, do you know which one to go to? Are you even aware that there's different ones? So maybe you have a requirement that all hosts should be validated to only go to localhost, and you fix it in one, and maybe you forget it in two. So the fundamental problem here is that, right, what you've done is you've actually introduced a new abstraction, a string that can be a URL, but you've not explicitly introduced that abstraction. And that leads to a fundamental disconnect between the methods on that abstraction and that abstraction in itself. And I've even seen teams go as far as do this, that they've defined a abstraction in a data class and then defined all the methods as extension methods. And this also completely breaks that coupling of that encapsulation of functionality that you'd expect on a domain object. So, I mean, there's a little benefit here in that what you could do is probably like import the different methods separately from the entity. But if there's a need for that, does that entity even make sense as a conceptual entity? So maybe you have a code smell there. So I would. This is definitely a code smell, and maybe just that. So what way should you go about this problem? Because of course, extending functionality of external classes is something that's really valuable. And like a common use case is, for example, if you're working with monetary values, and if you're smart about it, then you're working with big decimals. But now you want to calculate something about these monetary values. So you want to type value times 4 because you need 4 times this price. Maybe you've sold 4 items of this price. And now IntelliJ tells you, or any other ID, but I'm going to stick with IntelliJ because it's the best. Tells you that this doesn't work. And luckily, it also suggests for you how to fix it. You can just introduce this extension function. But we've discussed this issue. Maybe you introduce this or someone else does it everywhere else. So this is, again, that risk of duplication. So a better way to approach this is to actually introduce that abstraction that you're working with. So I've got it, money here is probably not the right name. Maybe monetary value is probably better, but you can work that out when you do it for yourself. But the beauty is that now you have an actual name for this abstraction that you introduced, this wrapper around the big decimal, and you can use an inline class to even not have a memory hit for that. And then you can put both those operator overloads that make sense for money, and but also conversions to other types or from other types, like this constructor from a number, which turns that into a big decimal. So that really gives you this nice encapsulation that object-oriented programming can provide you without having the problem of having scattered functionality about an abstraction that you've introduced without making it explicit. So to sum that all up, extension functions are absolutely great, but there's a couple things you need to take care of. They can introduce unnecessary duplication. They can break object encapsulation by exposing the inwards and by disjointing the methods from the object, and it can just basically interfere with introducing the right abstractions, because you're sort of implicitly introducing them without actually introducing them. So this we qualify definitely as dangerous. All right, let's talk about operator overloading. So this is one of those other Kotlin features that I love. I think it's a really cool modern language feature, and there's ways that you can use it really well. Like in this monetary value example, I've used it so that you can basically just calculate with money as you would. Well, this is only multiplication, of course, but you can multiply with money as you would with any other number or counted amount. But so yeah, this is great. Do this. But I have this thing, and if you're like me, you recognize this, is like calculations and algebra. I get really excited about math. I think mathematics is an amazing tool set to describe the world, because it provides really well-defined abstractions that are also a model with which you can make predictions about the world that are really relevant. So I tend to do this thing where like pretty much all of the problems I think about at some point get translated into mathematics in my head, and that really helps my personal mental models. But if those mental models don't align to others, it can lead to really bad situations. And that's the war story that I want to go into now. So the year is about, like, I think 2017. And as I said, I work in an online retailer, and we were working on valuating stock. So items come into the warehouse, and it was our job to figure out how much we paid for these items. And you might think that is a fairly trivial job, but at scale, no trivial jobs exist. But there's all kinds of factors that go into this. Like sometimes people just send you stuff in the hope that you will pay for them later, and things get lost. But also multiple suppliers might send you the same item for different prices. And there's things like stock depreciation. Like if you have it on stock longer, then you need to take a reservation against the value of that product. So there's all kinds of ways that this valuation of products can change. And fundamentally, we modeled that as a concept with two mutations, either stock transactions, so items can come in and out, and price transactions, and that's changes to the value of an individual item. And those two transactions combine together to create stock value transactions. And you can imagine that whenever a stock transaction takes place, it changes the value impact of all price transactions. And whenever a price transaction takes place, it changes the value impact of all stock transactions. And I was working on this project, and I explained this concept many times. And every time I did that, I explained it like, yeah, you have your delta in stock and your delta in price, and that multiplies, becomes your delta in stock value. And this was the way I balanced it. I modeled it out in my head, and this was the way I explained. So this was the first project we did with Kotlin. So when I found out that I could just do this, I was like, yes, eureka! This is exactly the language that implements what I have in my head. I'm like, yeah, I'm gonna build it like this. And I literally spent a week telling everyone how awesome Kotlin was for having operator overloads. But then something funny happens, you know. A new really good engineer, actually a friend of mine from a previous job that I pulled into this company, joined our team, and he didn't get this code at all. He had no clue what was going on here. And as I look at it, that makes absolute sense, because this code says that there is transactions, that is stock transactions times price transactions. So if I look at this sec, I just think, so that's A times B is AB. But this was actually a really complex operation. Under the hood, there was enrichment going on of figuring out different supplier IDs, figuring out, there was even, like, it was not even commutative, because certain price transactions, depending on the state of stock, could mean that some stock transactions had to be split into multiple transactions. So it's not even true that A times B is AB. So this was actually a terrible way to represent that code. But I got so hung up on, oh yeah, this is how I explained it, that I built it like this. And what I really failed to do there was empathize, something like that, with my fellow colleagues, and realize that my mental model is not the way what other people's is not other people's mental model. So let's talk about, to wrap it up, about operator overload. They're also absolutely great, but here we go. They really only work if the concept aligns. If the abstraction that you're putting this operator overload on is actually something that's actually countable, like a volume or a money amount. You know, as soon as these are complex objects, the operator overload actually hides the fact that you're talking about complex objects here, and that abstraction doesn't fit very well very often, especially if you're new to a domain. So in that way, it can really surprise readers of the code of hidden functionality. And as I said, you know, it's maths, it's gorgeous, but that does really make it risky for its seductive elegance. So yeah, officially a danger. All right, let's continue. Let's talk about lambdas with receiver. So I did have there we go, Discord up here. Right. So usually I do like a raise of hands here, but maybe we can use the chat. And I'm curious to see, like, maybe how many times have you used Kotlin in production, and how many times have you used lambdas with receivers? So these are, yeah, if you don't know what they are, you probably haven't used them. So if you want to go ahead and put that in the chat, that will be awesome. I guess there's a little delay here, so it might take a while, or people might have not used them at all. And then I guess I'll just continue. Because the point that I wanted to make about lambdas with receiver, I think this is one of these features that are fancy, but maybe a bit too fancy. So maybe people don't ever use that. And this is, I think, the one situation where I personally used it. And I think I still regret that. But in a way, this reads rather nice. So what the context of this code is that it sets up topics and subscription in a Google PubSub emulator before an application context starts. So these subscriptions and topics on production were managed by an external infrastructure configuration system. So we had to build them up for our emulator. And this is the code that did that. And if the emulator was fresh, then of course the deletes wouldn't need to happen. So we would just accept the not found under the hood. And the way that this code works in the PubSub admin is that there is this extension function here on ignoring not on the PubSub admin. And then that extension function receives a lambda with receiver here that is actually receives a PubSub admin. So that allows us to call this ignoring not found, and then within this lambda, just call methods on the PubSub admin method. And that's why I implemented it like that. I think that would be a nice way to do the different methods on PubSub admin with this concept of ignoring not found wrapped around it. But, and I'm still on the fence about this code, you know, but I think what the basic problem is here is that it doesn't pass the smartness check. I saw this on Devox sometime. I can't remember who said it, but he said, if I think about a line, oh, this is a really smart line, then I delete it. Because if the person who wrote it already thinks it's smart, then the person who's going to read it is never going to understand it. And then there's other more hidden concept first, because you're passing in this lambda with receiver to this object that's supposed to receive into this lambda with receiver, except there's no guarantee that that happens at all. So the person using this code really doesn't know at the point that it is called that this is going to have the result that he wants from it. And there's also, within the delete topic, there's a new scope that has the scope of this, of pub/sub admin. But the calling code doesn't communicate that. And of course, your IDE helps with that and tells you that. But if you need an IDE to understand the code, then you're losing lots of value in your code, because merge requests will be harder and sharing that code will be harder. So needing an IDE to understand the code, that's really a red flag for me. And I guess one of these other things that I don't like about this is that it makes it hard to think about what this refers to. And we know what that means. I mean, is this JavaScript or something? You know, it's I'll let you read this, but I cannot write a single line of JavaScript without thinking about this tweet. And I really tried to find the original author, but I couldn't find it. But oh man. So talking about lambdas with receiver, yeah, they're great. They're great fun, but here we go again. So they totally obfuscate context scope, and that makes it harder to understand the code. And it doesn't pass this smart code test, where if you've written a line that you think is smart, you should definitely delete it. And it turns Kotlin into JavaScript, and nobody wants that. Well, actually, that's what the compiler to JavaScript does, but that's why we have this compiler, so that we don't have to write JavaScript. So anyway, great danger is here. So now we're back to Alexander the Great, and also the point I wanted to make about this Chang'e 5, this awesome lunar mission that we have going on now, and that's that all these different parts of the mission, they really apply the right tool for the right job. It's not one big system that has to do everything, but it's really a well thought out system that optimizes for the specific thing that they have to fix. And that's also what Alexander the Great did when he cut the Gordian knot with his sword, like no one had ever realized. And that's the main point that I'm trying to make here, that there's so many awesome tools available to us, and there's so many hype-driven new tools coming out every day, that it's really important to not just join the flock of ducks, I guess this is, and try out all the new things, but really look at your problem, look at your code, and make sure that you use the things that actually make it better. And then if we all do that, then I'm sure we'll all sail off to a better place with better code for everyone. So that was my talk. Thanks a lot.